Biogeochemical cycles. Biogeochemical cycle is any of the natural pathways by which essential elements of living matter are circulated. The term biogeochemical is a contraction that refers to the consideration of biological, geological, and chemical aspects of each cycle. The importance of the biogeochemical cycles is that they are vital because they recycle elements and store them too, and also they regulate the vital elements through the physical facets. These cycles describe the association between living and non-living things in the ecosystem and enable the continuous survival of ecosystems. Relationship of the physical properties of the elements of the periodic table with the biogeochemical cycles. The physical properties of the elements of the periodic table have a considerable influence on the biogeochemical cycles. These cycles do not happen in isolation. For example, the movement of water is essential for leaching of nitrogen and phosphates into rivers, lakes, and oceans. The ocean is also an important repository of carbon. Although each element or compound has its own route, all these essential chemicals, nutrients circulate through the biosphere, moving between the biotic and abiotic worlds, and from one living to another, thanks to its physical properties. Relationship of the chemical properties of the elements of the periodic table with the biogeochemical cycles. Most of the chemicals on Earth are not useful forms for organisms, but the elements and their compounds needed as nutrients are naturally recycled in complex forms through the living and non-living parts of the biosphere, and converted into useful forms by a combination of biological, geological, and chemical processes. The cycling of nutrients from the biotype in the atmosphere, hydrosphere, and Earth's crust to the biota and vice versa takes place in the biogeochemical cycles, activated directly or indirectly by solar energy. Include those of the carbon, oxygen, nitrogen, phosphorus, sulfur, and water. Thus, a chemical may be part of an organism at one time and part of an organism's environment at another time. For example, a water molecule introduced into a plant may be the same one that passed through an organism of a dinosaur million years ago. Conclusion. How are the periodic tendencies of the elements manifested in biogeochemical phenomena? Ionization energy measures the tendency of an atom to give up electrons, and electron affinity measures the tendency of an atom to accept them. These two opposite tendencies can be combined in a single magnitude, that is the electronegativity. The electronegativity is an element is defined as the relative tendency of its atoms to attract electrons from other atoms which they are bonded. That is to say, the periodic tendencies of an element is manifested in biogeochemical phenomena, allowing links of chemical reactions to occur between the elements, generating their movement in each period of cycles and achieving that the elements are recycled. 2. How are the metallic and non-metallic properties of the elements manifested in the biogeochemical cycles? We can see an example of how the metallic properties of the elements are manifested in biogeochemical cycles when the soil degrades substances accumulated in it at such levels that they have a negative impact on its behavior. Metals at high concentration levels become toxic to living organisms in the soil. It is therefore a chemical degradation that causes the partial or total loss of productivity. But it is evident that these metallic properties are required to the proper proportions. The non-metallic properties of the elements are manifested in biogeochemical cycles by having varied appearances between gaseous, liquid, and solid. For example, gaseous like helium, soft like sulfur, and hard like diamond. These are not corrosive. They are poor conductors of electricity and heat. They are brittle, soft, or hard. They are not malleable, they do not reflect light, and they have lower melting points than metals.